Yes, sir.
Yes, sir.
If the central atom undergo sp2 hybridization, but it is not making 3 bonds. It has one lone pair in one of the hybrid orbitals. Only 2 are used in bonding. What is the shape of molecule, sir? What is the shape, sir?
Sir, once show previous slide, sir.
If central atom undergo sp2, but there is one lone pair, only 2 fellows are making bond. What is the shape of the molecule?
V shape.
Shape of molecule. Bent. Okay.
Yes, sir.
Sir, once show previous slide, sir.
Sir, if the central atom undergo sp3 hybridization, making 4 bonds. sp3 hybrid orbitals have 25% s character, 75% p character. What is the shape of the molecule, sir? Hello?
Tetrahedral.
Tetrahedral. Now, if the central atom undergo sp3, no doubt, but one position is lone pair.
Shape is trigonal pyramidal.
Yes, sir. Trigonal pyramidal. Central atom undergoes sp3 hybridization, but there are 2 lone pairs.
V shape.
Bend shape.
This V shape or bent. Bond angle is less than 109 degrees due to repulsion between lone pair. Here also bond angle is less than 109 degrees due to repulsion between lone pairs. Order of repulsion, lone pair repulsion is greater than lone pair, bond pair is least. We know all that. Sir, if the central atom undergo sp3d hybridization, these are axial bonds, these are equatorial bonds. What is the shape, sir? Hello, sir. What is the shape?
Tetrahedral.
Nah.
Trigonal bipyramidal.
It is diagonal bipyramid. I have made it to lie down because vertically I don't have place. Okay, I try vertically. This is vertical diagram. It is a horizontal diagram. Same thing. What is the shape, sir?
Trigonal bipyramidal.
If all are bond pair, shape is TBP. Suppose if one is lone pair,
Seesaw shape.
seesaw. sp3d with one lone pair. Suppose 2 are lone pairs.
T shape.
T shape.
If 3 are lone pairs.
Linear shape.
Linear shape.
Now in an octahedron, sp3d2 is octahedron. This is octahedron. Suppose in sp3d2, there is one lone pair. If there is one lone pair, sir, if there is one lone pair, what is the shape?
Square pyramid.
Square pyramid. Sir, if there are 2 lone pairs,
Square planar.
Square planar.
that's all, sir. If it is sp3d3, Shape is pentagonal bipyramid. Let's forget about that. Now, sir, you have to remember, this is very, very important. I'm not going to repeat now. This 5 minutes time is very, very, very important. All of you pay full attention. The valence electrons, available electrons for bonding in hydrogen is 1. For beryllium, it is 2. For boron, aluminum, gallium, thallium, it is 3. For carbon, silicon, germanium, lead, even tin, the available electron for bonding are 4. For nitrogen, phosphorus, arsenic, antimony and bismuth, for all these available electrons for bonding are 5. For oxygen, sulfur, selenium, tellurium, even polonium, available electrons are 6 for bonding. For fluorine, chlorine, bromine, iodine, available electrons are 7 in outer level for bonding. For xenon, krypton, etc., available electrons are 8 for bonding. This table you have to remember. How many electrons are actually available for bonding? Definitely you should remember for hydrogen, beryllium, boron, aluminum, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, xenon, halogens. It is good if you remember all this. Any difficulties there, sir?
No, sir.
Hello.
No, sir. No, sir.
Now, look at, for example, XeF4. Look at XeO3. Look at XeOF4. How XeF4 is looking like, sir? Let us classify every molecule into AB2, AB3, AB4, AB5, AB6, AB7 type, where B represents bond pairs. Sometimes central atom is not only having bond pairs, it can also have lone pairs. If it is having, say it is AB4E type, E means lone pair. You can classify it as AB3E2, or it can be AB2E3, where E is representing lone pairs. Some molecules may have lone pairs, some may not have lone pairs. Okay, sir? So you classify a molecule as ABXEY. Let us try to do this. Classify XeF4 to what type of molecule it is. How XeF4 is looking like?
AB4A2.
XeF4 is looking like AB4, but xenon has 8 electrons. Out of 8, 4 are used by 4 fluorines. Each bonded atom uses 1 electron. However, if oxygen is bonded, that takes 2 electrons. So xenon has total 8 electrons. Out of 8, 4 are used. Remaining 4 are remaining means there are 2 lone pairs. So XeF4 is AB4E2 type molecule. Can we do it this, sir? Let us look at XeO3. How it is looking like?
AB3.
It is looking like AB3. Xenon has 8 electrons. 3
AB3E1.
oxygens are using 6 electrons because
E2.
each oxygen. So it is
AB3E,
AB3.
sir.
Let us look at XeF4, 3. Xenon is the central atom A. It is bonded to 1 oxygen and 4 fluorines. Together 5 atoms it is bonded.
AB5E.
And now xenon has 8 electrons. Out of 8, 2 are used by oxygen and 4 are used by 4 fluorines. So how many are left, sir? How many are left?
2.
How many are
Lone
left?
pair. One lone
pair
pair.
of
So there is, yes, sir. So any molecule you can classify into this category. Let us take another case. Let us classify these cases. ClF3, it is looking like AB3. Any problem? Any problem? Now
sir.
Cl has
Yeah,
7
lone pairs.
electrons. Out of 7, 4 are used. I mean 3 are used.
AB3 too.
So,
Yes, sir.
is that fine?
Yes, sir.
Yes, sir.
Now I3 minus
Yes,
I
sir.
look as I2 minus. Then it is looking like AB2. And iodine has 7 electrons. Extra minus charge indicates 1 extra electron, 8. Out of 8, 2 are used by 2 iodines. So how many are left? 6. Means,
AB2 3.
can I do that?
Yes, sir.
Can you classify ICl2 minus?
AB2 A3, sir.
Now ammonium ion, it is looking like AB4. Nitrogen has how many electrons, sir? 5. But there is a plus charge, means 1 electron is lost. Therefore, now in ammonium ion,
4.
nitrogen has how many electrons? 4. All the 4 are used. So it
AB4.
is,
AB4.
Yes, sir.
let us look at carbonate. How it is looking like? Carbon
AB3.
has
AB3.
carbon has 4 electrons. There are 2 extra minus charges, means extra electrons, 2, 6. Each oxygen takes 2 electrons, 3 2s are 6. So it is simply AB3.
Yes.
So you classify any molecule into ABX, EY type. Y can be 0, Y can be 1, 2, 3. X cannot be 0. X must be minimum 2, 3, 4, 5, 6, even 7. If X plus Y value is equal to 2, say the hybridized state is sp. sp hybridization with no lone pairs is linear in shape, no doubt. If X plus Y value is 3, hybridized state is sp2. sp2 hybridized state can be trigonal planar if there are no lone pairs. It can be bent if there is one lone pair. If the X plus Y value is 4, it is sp3. sp3 is tetrahedron if there are no lone pairs. If there is one lone pair, it is a trigonal pyramid. If there are 2 lone pairs, it is V shape. If X plus Y value is 5, hybridized state is sp3d. It is trigonal bipyramid if there are no lone pairs. It is a seesaw if there is one lone pair. It is T-shape if there are 2 lone pairs. It is linear if it is having 3 lone
3
pairs.
lone pairs.
If the value is 6, hybridized state is sp3d2. If there is one lone pair, it is square pyramid. If there are 2 lone pairs, it is square planar. If the sum is 7, hybridized state is sp3d3. Shape is pentagonal bipyramid. Are we very clear about it, sir?
Yes, sir.
Now, any molecule, any ion, you can say what is the shape. Anything they can do. Let me quickly verify whether you can do it. SeBr4. You know, oxygen, sulfur, selenium, they have 6 electrons in the valence shell. What is the type and the shape of molecule?
AB4E, sir.
AP4E2.
Type of hybridization,
AB4E, sir.
4E, sir.
shape. It is AB4E1. Type of hybridization is
sp3d2.
sp3d. Sir, B plus E value is 5. So shape is, what is the shape? In trigonal Y pyramid, there is one lone pair.
Seesaw.
Trigonal pyramidal.
Seesaw, sir.
Diagonal bipyramidal, sir.
In trigonal bipyramid, one is lone pair. If
Sir,
one is lone
seesaw.
pair, seesaw. Can you see it really?
Yes,
Hello?
sir. Yes, sir.
XCO to F2. What is the type of molecule?
AB1.
Before even, sir.
AB4E1.
Seesaw shape, sir.
AB4
Even.
E1. Again, the type of hybridization is sp3. Again, shape is. Can you see it really?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Nitrate ion.
AB.
B3, sir.
Nitrogen has 5 electrons, but there is an extra minus charge, means you add 1 6. Yeah, and nitrate is looking
Sir,
like AB3.
trigonal
Out
pyramidal
of
shape,
6
sir.
electrons, all the 6 are used by 3 oxygen. So it is AB3. It is trigonal. AB3 it is. AB3 means hybridization is what, sir? You have to classify the molecule into ABX, EY. It is AB3, E0.
sp2 hybridization.
So X plus Y is equal to 3. Hybrid state is sp2. Now AB3 with no lone pairs and sp2 hybridization is trigonal planar. Any doubt on this, sir?
No, sir.
Hello? Yes. Sulfate ion. What is the type?
AB4.
AB4, sir. AB4.
Tetrahedral.
Hybridization is sp3.
P3.
Tetrahedron, sir.
Okay. XCF4.
AB4E2, sir.
before E2.
AB4E2.
Hybridization
sp3d2.
shape.
T shape, sir.
Planar.
Eh?
No, sir.
P3D2 means
Linear, sir. Linear
octahedral.
shape. Sir. Linear
In
shape.
octahedral, there are 2
Square
lone pairs.
planar.
Linear, sir.
What linear, man? sp3d2 means octahedron. In octahedron,
Square
there are
planar, sir.
2 lone
Yes, sir.
pairs
Yes, sir.
means
Correct,
square
sir. Yes,
planar.
sir. Correct, sir.
You
Square
should
planar.
see, you should develop this structure, man.
Yes, sir.
Yes, it is square planar. Okay?
Yes, sir.
Okay.
Sir.
Understood, sir.
Now, any pair of molecules or ions which have same number of electrons are called isoelectronic. If they are isoelectronic, they have same structure. So isostructural, they have same hybridization. A pair of molecules or ions which have same number of electrons are isoelectronic, they have same structure, same type of hybridization in the central atom. Like carbonate ion, nitrate ion. Okay? Like methane molecule, ammonium ion. Any pair which have same number of electrons are isostructural and they have same hybridization. Okay, sir? This is the shortcut about finding the shape and hybridization. This can be done in less than 30 seconds if you practice. Any molecule they can give. For example, I am giving you here. Your time allowed is 30 seconds. Let me see whether you can do it. Are you ready? Hello?
Yes, sir. Yes, sir.
PCl6 minus ion.
AB6.
AB6. Hybridization. What is hybridization?
sp3d2.
sp3d2.
What is the shape?
Octahedron.
Octahedron.
Done deal. Okay. Let me take XCO4.
AB4.
AB4,
AB4, sir. AB4.
AB4.
Hybridization.
SP3D,
sp3
Huh?
P3.
Shape.
SP3,
tetrahedron.
tetrahedron.
Tetrahedron, sir.
Very good. Next thing we are trying is PCl4 plus.
AB4.
AB4,
SP3.
Tetrahedron, sir.
sp3 tetrahedron.
Next I will take up. Okay. KRF2.
AB2E3.
AB2E3, sir.
Hybridization state.
SP3D.
Linear, sir. Linear. Shape is linear.
What is the hybridized state?
SP3D.
SP3D2.
sp3.
P3D,
D3.
D.
P3D, sir.
You should count. There is one s orbital, there are 3 p orbitals, there is one d orbital. Put together, it should be 5 only.
Yes,
You
sir.
can't say sp3d2. If you say sp3d2, the total will become 6. You want only 5. Notice, sp, one s, one p, sum must be 2. sp2, sum must be 3. One s, 2p. sp3, sum is 4. sp3d, sum is 5. sp3d2, sum is 6. The b value, c value, sum should indicate the type of hybridization. Can you see that clearly? Hello?
Yes, sir.
Yes, sir.
So, KRF2, AB2E3, hybridization is sp3d, shape is
Linear shape.
linear.
linear. Perfect. Now I think you have learned what is required to be learned.
Yes, sir.
So many students will take 2 hours time to learn it, and you have learned it in 10 minutes. Congratulations. I think you have learned it. You want me to make a YouTube video on this or not required?
Yes, sir. One YouTube video.
We want, sir.
Anyway, I
We
will-
want, sir.
but
You
by
want-
and large, you have learned it. I think you have learned it. Okay. You can see some questions on this topic. Tomorrow we talk about molecular orbital theory. That is the next theory. But now I will give you some questions on this. Okay. If you are looking at chemical bonding, in 2020 they asked 2 questions from this in NEET exam. In IIT mains exam, out of 25, they always ask 1 or 2 questions from this. Because IIT mains papers, no 2 students get same paper, and there are number of papers. Because online exam means there are so many sessions, 4 sessions in every 6 months. So these questions are must. But if you see NEET paper, 2020 they asked 2 questions. 2019 2 questions. 2018 3 questions. 2017 3 questions. 2016 2 questions. On an average, they are asking 2 to 3 questions in this topic. And now let us look at a standard question on this.
Can you please forward PDF to the WhatsApp group?
Excuse me, sir.
Can you please share this no PDF to the WhatsApp group, sir?
What do you want me to send? This book?
This, yes, this book.
Well, there are so many books, don't worry, I will send across. They have no problem. Wait. Which structure is linear? SO2, CO2, CO3 2 minus SO4 2. Which is linear?
CO2. CO2.
AB2 type molecule is linear. We know that. Mhm. The BCl3 is planar, whereas NCl3 is pyramidal because
D, sir. BCl3 has
Option D.
equal.
Option D.
D, sir,
perfect.
D.
In a regular octahedral molecule MX6, the number of XMX bonds at 180 degrees. How many bonds are at 180 degrees? In
One.
octahedron. How
Three.
many are at 180 degrees?
3, sir.
You have to see octahedron, man. In octahedron, how many bonds are at 180 degrees? Is it 3? Yes? Think it over. Obviously, it is 3. Can you see it or not?
Yes, sir. Yes,
Yes,
sir.
sir.
3.
Yes, sir.
Question number 70. Which of the following two are isostructural? Who are isostructural? Those which have same electrons, which have same type of molecule.
C.
Perfect.
Option C.
Perfect. Question number 71. In which of the following bond angle is maximum? sp2 bond angle is 180. sp bond angle is 180. sp2 120. sp3 109 degrees. You know all that. In which case bond angle is maximum?
D.
In B, that is AB2 type molecule, AB2E2. AB2E2 means the hybridized state is sp3. sp3 means tetrahedral. Tetrahedral means bond angle is 109 degrees 28, but there are two lone pairs, it will be 104. In SCl2, bond angle is 104, as in water. In PCl3, like AB3E, ammonia, bond angle is 107. In ammonium ion, like CH4 tetrahedral, bond angle is 109 degrees 28 minutes. So in which case bond angle is more, sir?
C.
A.
I don't know, you have to work out when. SCl2 is like water. In water, bond angle is 104. Ammonia is pyramidal, bond angle is 107. PCl3 is like ammonia. Ammonium bond angle is 109 degrees 28. Maximum bond angle is there in ammonium ion. You have to work out, right? Yes. Whenever the central atom is in third period, like phosphorus, it has d orbitals. If it has d orbitals, it can have d pi p pi bonds. Second period elements like nitrogen, carbon, boron can never make d pi p pi bonds with oxygen or anybody. See the question number 72. Which can have p pi d pi bond? A, B, C, D. Which can have?
C.
Answer is phosphate because others don't have d orbitals.
Yes, sir.
Okay. Look at question number 73.
Sir. Sir.
Yes, sir.
Sir, can you please re-explain P pi D pi bond?
You are worried, sir. Who will have d orbitals? Only third period onwards, atoms will have d orbitals. D orbitals are not present in second period elements. They have only two shells. To have d orbital, you require an element of third period, fourth period, fifth period, so on. If you are looking at A, B, D options, the central atom is nitrogen or carbon, which is there in second period. Only C, phosphorus is in third period. To make p pi d pi bond, it should have d orbitals. Only phosphorus has d orbitals. Answer is C. Sulfur has d orbitals. Third period elements have d orbitals. Second period elements don't have them. Second period elements, only second shell is filled. You know that. So 72 d pi p pi are possible only in phosphate. Look at question number 73.
D, sir.
Option D, sir.
Perfect. Question number 74. Hello.
B.
Question number 74, which is planar?
Option B, sir.
Yeah, that is square planar. SF4 is seesaw. NF3 is pyramidal. SiF4 is tetrahedron. Question number 75. Yes, sir, 75.
Yes.
Option
C, sir.
C, sir.
Option C is perfect. Yes, sir.
The cylindrical shape of alkaline is due to.
And that's
Sir,
next
B, sir.
question. Let's not go to there. Let's not go to there. Only let's confine to this. Because about alkynes we have not yet discussed. We have seen this. Okay, sir. Question number 82.
CO2, sir.
Sir, option D.
CO2 is linear. Yeah.
The following has shortest carbon bond length.
Sir, option C.
Yeah, because that is sp hybridized. It means whenever there is sp hybridization, bond length is shortest than sp2. sp2 is shorter than sp3. More is the s character, shorter is the bond.
In compound X 109 degrees.
In compound X, all the bond angles are exactly 109 degrees, 28 minutes. Means perfect tetrahedron. Which is perfect tetrahedron? Is it chloromethane
CCl4.
CH3Cl? Is it CCl4? Is it
Carbon
CHI3? Is it
tetrachloride.
CHCl? Because all are identical atoms. CCl4 must be the answer, right? So you are able to answer some questions. I congratulate you, you have learned it, right?
Sir.
Look at question number 58.
Sir, B. Sir, BF3.
Not only BF3, one more option is there.
BF3 and NO2 minus.
BF3 NO2
Perfect.
minus.
Option C.
Perfect. A bit difficult question. In which of the following pairs of molecules, ions, central atoms have sp2 hybridization? Same question.
Sir, NO2 minus
B
and
option. Huh?
Sorry, sir.
What is the answer, sir?
Sir, BF3 and NO2 minus.
BF3 and NO2 minus.
Perfect. Just now we have seen BF3 and
Sir.
NO2. They ask you 2 times same question. Look at question number 52, more difficult question.
Yes, sir.
Sir, NO2 minus is AB2 type molecule, AB2E type. NO3 is AB3 type.
Yes,
They are
sir.
different, right? AB2 E type, AB3. Both have same hybridization, right? The question is, both have the geometry that is explained by same hybridization. Both have same hybridization, but shapes are different. NO2 is bent, NO3 is trigonal planar, but they have same hybridization. They want same hybridization, right?
Option A.
Option A. If you are looking at B, NH4 plus is AB4 type sp3 hybridization, and NO3 minus is AB3 type sp2 hybridization is differing. SCN minus is a complicated case where C is the central atom that is bound to two atoms, S and N. That is complex, but that is linear. NH2 minus is like AB2,
AB2,
AB2, hmm,
B2, E2.
E2, AB2, E2. AB2, E2 means sp3 hybridization. Answer is only A because they want same hybridization.
the D also same hybridization, sir.